Weather is everywhere. It affects all of us in various ways. The type of clothes we wear, the things we do outdoors, ways in which we get around, and for some, even how we do our jobs. Because weather can have a big influence on so many aspects of our lives, it is helpful to understand what weather is. Understanding weather is not only helpful when making personal plans, but can actually be critical when it comes to severe weather conditions like blizzards or droughts. Welcome to Weather Concepts Video Quiz. Hi, my name is June Vaught. Today, you are going to learn some interesting facts about weather. Listen and watch carefully. In a few minutes, my friends are going to ask you some questions. Pay close attention because all of the answers are in the presentation. So what's responsible for our weather? Believe it or not, the power source is 93 million miles away. That's right, that great big yellow ball of gases, our sun, is the source of energy that drives our planet's weather. And what a powerful source of energy it is. Weather and climate are two very important terms that are key to understanding what is going on in our atmosphere. Weather is the condition of our atmosphere over a fairly short period of time, typically in terms of hours or days. For example, if you are planning a fun outdoor weekend with your friends, you should probably check the weather report on a local news station, or read the weather report in your newspaper and find out what the forecast is for the next several days. Climate is also the condition of our atmosphere, such as rain, wind, or changes in temperature. The difference is that it is for a long period of time. Climate describes the weather of a certain area over years, decades, or even thousands of years. For example, if you are writing a science report about the climate of a particular region in the United States, your research would include information about how the conditions of our atmosphere have changed over a period of decades, hundreds, even thousands of years. So weather is the term we use to describe the day-to-day conditions of the atmosphere. Climate is the term we use to describe the long-term atmospheric characteristics of an area. We call the branch of science that deals with the study of a planet's atmosphere and its phenomena meteorology. The men and women who study meteorology are called, that's right, meteorologists. They study the conditions of our atmosphere, including its weather and climate. Meteorologists observe, record, and collect this information so they can share it with people around the world. It is important to understand how the Earth's tilt and rotation affect weather. First of all, our planet is rotating on its axis. This axis, which is an imaginary line, is tilted at 23.5 degrees. Because of this tilt, during varying times of the year, different latitudes receive different concentrations of the sun's energy. That means some areas will be warmer, while some areas will be cooler. Latitudes are imaginary lines that divide our planet into regions. Each region has its characteristic temperature range. The regions are polar, mid-latitudes, and tropics. Because of its latitude, an island on the equator is in a location that receives more sunlight and will be warmer than a polar region that receives less sunlight and therefore experiences cooler temperatures. Latitude is one factor that determines the type of weather found in a particular region. Areas north of the equator experience the longest day of the year on or about June 21st. This is called the summer solstice. During this day, the northern part of our planet tilts most toward the sun. This is the beginning of summer in the northern hemisphere. Meanwhile, on the opposite side of the Earth, in the southern hemisphere, it is the first day of the opposite season, winter. The winter solstice happens about 6 months later, on or about December 21st. Because the northern part of our planet is tilted away from the sun, it is the shortest day of the year. It marks the beginning of winter in the northern hemisphere. And of course, in the southern hemisphere, the opposite is occurring, and it's the first day of summer. Spring and fall occur halfway between the winter and summer solstices. During both of these times, the Earth receives equal amounts of sunlight and darkness in both hemispheres. Now, combine Earth's tilt with the constant rotation of our planet. The Earth rotates, or spins, in a counterclockwise direction. The combination of tilt plus our planet's rotation has a very powerful effect on Earth's weather. Here is an example of how this works. Imagine you are a superhero and you hit an object such as a baseball from the North Pole toward the equator. The baseball will appear to leave its path and deflect to its right. In the southern hemisphere, just the opposite occurs and the baseball appears to move to its left. This phenomenon is referred to as the Coriolis effect. Just like the path of a superhero's baseball, the Coriolis effect impacts wind and ocean currents. In the northern hemisphere, as wind and ocean currents travel from the cold polar regions and head toward warm tropical regions, these currents will tend to move to their right, or in a clockwise direction. In the southern hemisphere, they will tend to move to their left, or in a counterclockwise direction. When meteorologists observe our atmosphere, they are examining several layers. The layer that is most dense and lies closest to the Earth's surface is the troposphere. The name of this 10-mile thick layer comes from the Greek word tropos, which means churning. This is quite appropriate because this is where winds, precipitation, and cloud formations occur. It is a very active layer. Above the troposphere lie other layers: stratosphere, mesosphere, and thermosphere. These layers provide a protective blanket around our planet. Can you imagine what life would be like if intense heat from the sun stayed only in certain bands around the Earth? Some areas would be extremely hot, and others would be extremely cold. Fortunately, our atmosphere is always working hard to take the sun's energy and move it around in an attempt to even out all of those wild temperatures. Through the energy transfer processes of conduction, radiation, and convection, heat is transferred all over the planet. With conduction, heat energy moves from one object to another through physical contact. Because of conduction, heat transfers into some of the substances found on the Earth's surface, such as rocks, soil, and sand. Let's take a look at how this concept works. You are heating soup for dinner, and you leave a metal spoon in the pot as the soup heats up. After a few minutes, if you pick up the spoon, it will be very hot. This is because the heat moves from the stove to the pan to the spoon, and then, you guessed it, to your hand. This is how heat transfers through conduction. A second way that heat is transferred is by radiation. In this case, heat energy is transferred through light, heat, and some other type of electromagnetic wave. Because of radiation, the sun's energy travels long distances through space in waves until they reach the Earth. Here is an example of how radiation works. You are doing yard work on a sunny day. After working for a long period of time, you may feel the sun's energy on your skin. If you have ever had sunburn, you already have experience with radiation. The third type of heat energy transfer is through convection. When fluids such as air or water are hot, they carry heat with them. As they travel to areas that are cooler, they transfer their heat energy and warm up surrounding fluids. Through convection, warm air and water transfer heat to cold air and water. Think of it this way. Let's say you fill a sink with water. Before washing your face, you notice that the water is a little on the cool side, so you add some hot water. Because of convection, the hot and cool water will mix, eventually making all of the water in the sink nice and warm. Our atmosphere is always working to create a balance in air and water temperatures. Because of these heat transfer processes, our atmosphere does not get too cold, nor does our land get too hot. Wow, we have covered a lot of information. It's time for my friends to ask some questions to see how well you understand weather concepts. Have your paper and pencil ready. Let's do questions 1 through 10.
Construction sites can be very dangerous. We wear hard hats to protect us. Try this one on for size and answer this next question.
Question 1. When we talk about climate, we are talking about A, the state of our planet's atmosphere hour by hour, or in extreme cases, minute by minute. B, the weather across a particular area over a long period of time. C, only rainstorms that can cause severe flooding. Or D, the amount of sunlight reflected off of large white clouds.
Let's follow the rhythm of my drums to the next question.
Question 2. A meteorologist is someone who A, studies the movement of the Earth's crust, B, only announces weather forecasts on local radio stations, C, studies weather and climate, or D, observes and records the movement of stars and planets.
Round it up, y'all. It's time for me to ask you this next question.
Question 3. Most of our planet's weather occurs in the troposphere. Tropos is a Greek word that means A, moving and churning, B, stays the same, C, affected by gravity, or D, dense and heavy.
Being a great detective, you really need to figure out what is going to happen before it does. Let's see if you can figure out what this next question is.
Question 4. Because the Earth's atmosphere works with the sun's energy by moving it around, it keeps A, just enough oxygen available on Earth for animal life to flourish, B, the total yearly precipitation in equal amounts on all of the continents, C, the Earth spinning smoothly as it orbits the sun, or D, our atmosphere from getting too cold and our land surface from getting too hot.
I sure wouldn't want to be nose to nose with a rhinoceros, but I sure would like to hear the next question.
Question 5. You were in the school parking lot visiting with friends on a hot sunny afternoon. As you lean against a friend's van, you notice the heat from the van is transferred to your back. This transfer of heat is an example of A, conduction, B, radiation, C, osmosis, or D, convection.
It's a hunter here. I'm looking for some amazing questions, and I thought, what a better place than this cave? Why don't you figure out the answer to this next question?
Question 6. Radiation from the sun is one way that heat energy can travel long distances. When this occurs, it's through A, the gravitational pull of the moon, B, vibrations from sound waves, C, electromagnetic waves, or D, heat transferred through physical contact.
Keeping the truck in pristine condition is always important. Wait a minute, what's a question doing in here?
Question 7. Our planet is always trying to balance the different ocean temperatures by mixing warm tropical waters with cold Arctic waters. This transfer of heat energy is called A, radiation, B, convection, C, conduction, or D, desalinization.
Forecasting sure takes a lot of practice. Why don't you try your skills on this?
Question 8. True or false? The region's latitude is one reason why some places on Earth are warmer than others.
Oh, hi there. I'm just trying to find where I can go next. Find the answer to this next question.
Question 9. On the first day of summer, the Northern Hemisphere experiences A. The least amount of sunlight in one day, B. Equal amounts of sunlight as that received on the first day of fall, C. The hottest day of the year, or D. The longest day of the year.
Check out what's cooking with this question.
Question 10. Imagine an airplane flying in a straight path from the North Pole toward an island located on the equator. As it travels, the Earth rotates out from under it, causing the airplane to curve in a clockwise direction. This phenomenon is known as the A. Doppler effect, B. Coriolis effect, C. Echolocation effect, or D. Global positioning effect.
Welcome back. Good work. You can put your paper aside for now, but stay focused because we're going to ask you more questions later. Now let's look at some other interesting weather concepts. The water cycle is very important to weather. The sun heats water, which causes it to evaporate. This water vapor remains in the atmosphere until it cools and condenses. Eventually, it cascades back to Earth as precipitation, and the cycle starts all over again. This precipitation can appear in a variety of forms, such as rain, hail, or snow. Most evaporation and precipitation occur over the oceans, which cover more than 2/3 of our planet. As a result, our vast oceans are a major player in the weather action that takes place in the troposphere. Storms often stir up our most exciting experiences with weather. The energy needed to fuel storms can come from temperature and pressure differences between air masses. Air masses are large bodies of air that can take anywhere from a few days to a couple of weeks to form. They can stretch 1,000 miles across several states and stand several miles high. Air masses like to form in areas that are relatively quiet in terms of atmospheric activity. This is why they usually form in fairly stable air, such as that typically found in polar or tropical regions. Land and water play another important role in the development of these air masses. Large bodies of land plus large areas of water influence the temperature and humidity of the air masses that develop above them. This means that air masses take on the characteristics of the locations where they form. For example, an air mass that forms over a warm tropical ocean becomes warm and humid. An air mass that forms over frigid land becomes cold and dry. When looking at the 4 types of air masses that influence the weather in the continental United States, it is helpful to understand some key words. Polar relates to regions around the North and South Poles. Tropical has to do with warm areas close to the equator. Maritime deals with things related to the ocean. Continental refers to land that makes up a continent. These words describe the 4 types of air masses and their unique characteristics that influence most of our nation's weather. The resulting air masses and their main characteristics are the continental polar air mass, which is cold and dry, the maritime polar air mass, which is cool and humid, the continental tropical air mass, which is hot and very dry, and the maritime tropical air mass, which is warm and very humid. As air masses and ocean currents move around our planet, they are balancing its heat energy. This occurs by moving frigid air and water away from polar areas toward warmer tropical regions. Meanwhile, steamy air and water move away from tropical areas toward colder polar regions. Air masses are on the move and sometimes bump into each other. The boundary where two air masses of different temperatures meet is referred to as a front. It is usually along these fronts that much of our weather occurs. A cold front is when cold air mass moves into an area and pushes under lighter warm air, which causes the warm air to rise. As the warm air rises and mixes with cooler air, clouds usually form that often bring dramatic storms that release rain. A warm front is when a warm air mass moves into an area and slides on top of heavier cold air. As the warm air rises and cools, clouds usually form and often release rain or snow. Occasionally, an occluded front will form. This happens when a cold front overtakes a warm front and collides into the tail end of a previous cold front. Sometimes a stationary front occurs when neither the cold front nor the warm front replaces the other one. In this case, the air masses stay in one place for a period of time. Sometimes the result is precipitation that falls in one place for a long time and can cause severe flooding. Air pressure also has a big influence on weather. The number of air molecules in a given space, plus the speed at which these molecules are moving, determine the air pressure. If there are few molecules in the air, it is a low pressure area. If there are a lot of molecules in the air, it is a high pressure area. Air pressure is always trying to balance out. It moves from regions of high pressure to areas of low pressure. When a high pressure moves to where a low pressure is, the result is moving air or wind. Wind is important to the weather. It is key in moving and mixing air and water of different temperatures. Remember, our planet is always working to balance its different temperatures. This dance of hot and cold is happening all the time, all over the planet. We covered a lot of important information about weather. I hope you were paying attention because my friends are back to ask more questions. Have your paper and pencil ready. Here are questions 11 through 20. Good luck.
Driving a loader takes lots of practice, so you better practice with this next question.
Question 11. The path that water takes through evaporation, condensation, precipitation, and back to evaporation is called the A. Water cycle, B. Geothermal cycle, C. Hydropower cycle, or D. Circulation cycle.
Behind every great song, there's a great drummer. Let's see if you know the answer to this next question.
Question 12. True or false? Air masses almost always form above areas that have very unstable air and a lot of wind.
Looks like a storm's aheaded this way. I've got to get the livestock in the barn. Looks like you guys are going to have to answer this question on your own.
Question 13. True or false? The Earth tries to maintain a heat-energy balance by mixing cold air and water from polar regions with warm air and water from tropical regions and vice versa.
Shh! I've been following this next question for quite a while, and I almost have it where I want it.
Question 14. The number of air molecules in a given space combined with the speed of those molecules determines A. The speed of oxidation, B. The date of spring equinox, C. How effectively a stand of trees can block a strong wind, or D. Air pressure.
I bet that elephant can find the next question with its trunk. Let's find out.
Question 15. True or false? Wind is caused when different air pressures try to balance out and a high pressure pushes toward a lower pressure.
Today we're on the lookout for the next question. Now it likes to surprise people, so keep your eyes and ears open.
Question 16. Cold air masses move southward toward the equator and warm air masses move northward toward the North Pole. The place where these two air masses of different temperatures collide with each other is called A or an A, ionosphere, B, polar region, C, front, or D, weather cell.
While I crank this open, why don't you guys crank out the answer?
Question 17. When cold fronts and warm fronts collide, they are often accompanied by A, increased sunlight, B, some form of precipitation, C, severe snowstorms that last for several days, or D, a decrease in precipitation.
What a beautiful fall day. While I admire my surroundings, why don't you answer this next question?
Question 18. When a cold air mass takes over to replace a warm air mass, it's called a cold front, B, warm front, C, occluded front, or D, stationary front.
Woo! There's nothing like the wind in your face as the wall flies by. Now use your knowledge and answer this next question.
Question 19. The type of air mass that usually brings warm and very humid air into the United States is the A, continental polar air mass, B, maritime polar air mass, C, continental tropical air mass, or D, maritime tropical air mass.
I know it's here somewhere. Aha! I've got the recipe for the next question.
Question 20. Most precipitation and evaporation on Earth occur A, around large mountain ranges, B, over the oceans, C, at the highest levels of our atmosphere, or D, during the coolest part of the day.
Thank you for joining my friends and me. I hope you enjoyed today's exploration. The next time you step outside, think about all that is going on in the atmosphere to create the weather conditions you are experiencing. We covered a lot of information. Now let's cover the answers to today's questions.
Answers. Question 1. B. Climate is the weather across a particular area over a long period of time. Question 2. C. A meteorologist studies weather and climate. Question 3. A. Tropos means moving and churning. Question 4. D. Our atmosphere works with the sun's energy by moving it around, which keeps our atmosphere from getting too cold and land from getting too hot. Question 5. A. Feeling the heat of your friend's van through your back is an example of conduction. Question 6. C. Radiation from the sun travels long distances through electromagnetic waves. Question 7. B. Our planet tries to mix the temperatures of warm and frigid ocean waters through convection. Question 8. True. A region's latitude is one reason why some places on Earth are warmer than others. Question 9. D. The first day of summer in the Northern Hemisphere is the longest day of the year. Question 10. B. An airplane traveling in a straight path from the North Pole toward the equator will deflect to the right as a result of the Coriolis effect. Question 11. A. The path that water takes as it goes through evaporation, condensation, and precipitation is called the water cycle. Question 12. False. Air masses typically form in areas that have fairly stable air, like polar or tropical regions. Question 13. True. Our Earth works to maintain a heat-energy balance by mixing cold air and water from polar regions with warm air and water from tropical regions. Question 14. D. The number of air molecules in a given space combined with the speed of those molecules determines the air pressure. Question 15. True. Wind is caused when different air pressures try to balance out and a high pressure pushes toward a lower pressure. Question 16. C. The place where these two air masses of different temperatures collide with each other is called a front. Question 17. B. When cold fronts and warm fronts collide, they are often accompanied by some form of precipitation. Question 18. A. When a cold air mass takes over to replace a warm air mass, it is called a cold front. Question 19. D. The type of air mass that usually brings warm and very humid air into the United States is the maritime tropical air mass. Question 20. B. Most precipitation and evaporation on Earth occur over the oceans.